Hello and welcome to today's daily Leetcode challenge. Today we'll be solving question 2482, difference between ones and zeros in row and column. Medium level question. Let's get to the description. You're given a zero indexed m by n binary matrix grid. Zero indexed m by n difference matrix diff is created with the following procedure. So we're given an input matrix of dimensions m by n that is binary, and we have to return the same a similar dimensioned matrix called diff, and this is how it's going to be constructed. Let the number of ones in the ith row be row 1 row. Let the number of ones in j column be ones column. Let the number of zeros in ith row be 0 row, and let the number of 0 in jth column be 0 column. So we're given, we're breaking down the number of zeros and ones in each column and then in each row, and that gives us these four variables. And so then each element, each cell in the return matrix diff is going to be constructed with having, by adding the ones in the row in that row, the ones in that column, and then subtracting the zeros in that row and the zeros in that column. Okay, and then it gives us some examples. Cool. Well, I don't think this is a very difficult problem. Probably what the difficulty here is breaking down and calculating all of these variables. But once we have all of those variables, it's simply going to be creating this diff matrix by populating it using this formula. So without any further ado, I'd say let's think of the solution. The solution should probably be, I'm going to simplify some of these four elements or four variables. I know that the number of ones in a row is equal to the total number of, let me rephrase that. The number of zeros in a row is going to be the length of the row minus the number of ones in the row. So we can actually omit having to calculate two of these entirely. And once we know that, we are left with these two variables that we need to have ad hoc when we're calculating the response. And so suggestion here would be to maybe pre-calculate the number of ones and the number of rows in the input grid by just simply having two arrays representing it. The ones array, the ones row array is going to be representing the number of ones in each row. The ones call array is going to be representing the number of columns in the number of ones in each column. That's pretty easy to do, so let's begin. Let's first say have some basic variables here. I want to know the length of my grid, or I want to know the dimensions of the grid. This is going to be the row length. And actually, I've been having issues with this. Let's rename this to n, right? M by n. N is going to be grid, len of grid. We should see a 3, 3, and a 2 by 3. 3, 3, and a 2 by 3. Let's check that to make sure that everything is right. 3, 3, and a 3, 2. I have already messed it up. What is it? M by n? M by n. So, oops. m by n. There we go. So 3, 3, 2, 3. That's going to help us. 3, 3, 2, 3. Awesome. Okay, now for calculating the ones row and the ones column. Let's say ones row count is equal to, and I'm going to use something clever here. This is a way to basically spread and populate this inner array. Sum of row for row in grid. You'll see that once for each row, which is an array. In a grid, we're going to run this function, and it's going to populate it with that value. One's call count can be done in a very similar way, except for call in, and here we're going to do something. Grid. We're going to spread the grid into its adjacent rows, and then zip actually takes the elements by their indices. So all elements in the spread arrays are going to be representing this column, such that at the end of the day you get something like this. Row count, and let's call count. You'll see that now we have a ones row count and a ones call count. The ones row count goes by 2, 2, 2, 2, 1, and the calls go 1, 1, and 3. Perfect. Now that we have that out of the way, it's really just time to get the difference matrix created and populate it with the correct values. Here I'm going to start off with just zeros times the length of the row, and the m by n matrix. N is going to be the length of the row for nothing in range m. I'm doing these intermediate checks consistently because I tend to have problems. I pretty often have problems messing up these variables. So it looks like we're good here. The row's length matches up with the input, and the row column and the column count also matches up. So now we're simply going to say for, let's say, I is going to be iterating over the row index for in range m. For j in range n, j is going to be iterating over the column index, and I already messed that up. No, I is going to be looking over the column, which row we're looking at. J is going to be representing which column we're looking at. That's a better way to say it. Okay, and now let's calculate these variables here. We have the count of the ones, but let's do zero count for that specific row, and that's going to be simply the length of n minus row looking at a specific row we have to look at, okay, I'm confusing myself again. I believe that it's I. The reason that it's I is because one's row count represents how many rows are in, how many ones are in that row. And since we have 2 rows, then we need to subsequently only go over the 2 possible rows that are there. The rows are being represented as m. Cool. 0, let's do 0 row count. 0 call count is equal to m minus 1's call count j. Cool. Let me just print all of these values one more time to make sure that I'm getting them correctly. Print. And there's absolutely no shame, in my opinion, of doing these intermediate checks because they do get you. Print I and j. So the first example isn't going to be that incisive, but the second one, ooh, that's not helpful. Okay, how about this? We're going to be looking at a 0, 0. Oops, this is for the second. I want the second case. 0, 0, and these go in pairs. So 0, 0 is the number of ones in that column is 3. The number of zeros is 0, correct? For this, the number of ones in a column is 2, and the number of zeros is 0. And this all looks good. That was just a quick check. Now let's populate. Let's say that diff hat I and j is equal to, and then we just plug in these values. Ones per row plus ones per column minus zeros per row count minus 0 per row's column. We should be good. Let's return this and see if we're set. We're getting an accepted solution, and that's it. Sweet. Let's see how well we do compared to everyone else. 76th percentile isn't great, but let's see if there are more novel solutions. Don't understand that. How about this? M and N, ones per row, ones per column. They populate the ones per row and ones per column, and then they, oh, okay. Well, instead of here, what they're doing is instead of using a difference matrix that I created, they're actually reusing the grid, which is a solution, and we could try doing that. I know that it's not going to break any of our code. Let's see if this speeds up our solution. Although this is kind of nitpicking, and it might not even be that much better in terms of like just the practices of writing code. However, if it speeds us up a little bit, which it did, sure, I would say this works as well. It removes the need to create a whole another output array, and we will probably be using less memory as well. Okay, well, with that, I would say, yeah, stick to this solution. If you have any questions, please leave a comment. And that's it. Thanks for watching. Please like and subscribe. It takes and helps out the channel. Bye.